The main purposes of the buildings are to prevent its inhabitants from the impact of the outside environment and to create a comfortable inside living environment. The complex of the factors of the inside living environment are called microclimate, and the word comes from the Greek word micros, which means small, and their main purpose is to ensure a comfortable living. It's a complex of physical factors of the living environment in a closed space that cause some impact upon body functioning, and they are artificially created climatic circumstances of the inner living environment. The requirements towards that inside circumstances of living um, are different according to the function of the building, according to the function that happens in each different room of the building, and always consider a combination of factors. So the factors of the microclimate are a group of factors that can be controlled uh, through design or through adding active systems, and a group of factors that cannot be controlled. The controlled factors are the temperature, the air temperature, the air humidity, uh, the movement speed of the air quality, light comfort, and acoustic comfort. The group of factors that cannot be controlled is the age of the inhabitants, their health condition, some individual neurological specific moments, the clothes they prefer to wear, and of course what should be considered, but architects don't have control about it, is the degree of activity supposed to happen inside a given room. The parameters of the microclimate can be accepted or optimal, and they are set according to the age of the inhabitants and the function of the room, and also according to the outside climate conditions. The comfort feeling can be objective, based on physiological reactions of the body, and it's a combination of conditions ensuring optimal functioning of the body. And it's the base of the normative sets of requirements. The other feel of comfort is subjective, and it's psychological, and it regards the combination of conditions which majority of inhabitants say it's comfortable enough, but it is cannot be a base of strict normative requirements. Human body exchanges heat with the surrounding environment in four different ways. The first one is conduction, and it's a transfer of heat to a cooler surface by direct contact. The second one is convection, when the heat is taken away from the human body and transferred to other objects using the air movement, or in sometimes it can be water. Um, the third way is radiation. It's a transfer of heat via electromagnetic waves. And the fourth way is evaporation through sweating, and a smaller degree through human breath. Sweating actually cools human body, following the rule that going from lower condition liquid to upper condition vapor, the water extracts uh, heat energy, thermal energy, and this way cools the outer layer of the skin. The factors that cannot be controlled are the extent of physical activity, the preferred way of the preferred walls, the age of the inhabitants, and the health condition. And of course, the extent of the adaptivity of each single inhabitant. But they have to be considered when designing the microclimate. Factors of the microclimate. The first and most important is the temperature of the air, um, which differs according to the outside atmospheric conditions and the season. And when the season is cold, the requirements towards the inner temperature is a little bit higher, and when it's hot, of course, the requirements are for lower temperatures inside. Um, and when the temperature of the air goes below 25 degrees, some or lower than 15 degrees, some extensive discomfort can be seen. Also, the temperature requirements, the temperature optimal um, levels differ according to the to the function of the room. For instance, in residential buildings, the sleeping room has requirements for lower temperatures, and also kitchen, staircase, and some sanitary rooms and closets. They also need lower temperatures. While as in the bedroom, where people often are without clothes and get wet also, um, there is a higher requirement for temperatures, about 25 degrees, and in nursery rooms also a little higher temperature, about 23 degrees, is required. Also, studies show that the difference of temperatures between the floor and the the head, between the feet and the head, is the optimal difference is about 3 degrees, and the feet like warmer temperatures, and the head likes cooler temperatures, but not more than 3 degrees difference. The other thing that is important is the extent of physical activity, um, and there is about 10 times difference of the energy used by the human body when it's relaxing and when it's doing some highly physical activity. And it considers, for instance, whether we will have a study classroom where students will sit and just listen, and a gym where some sport will happen. Important also is the clothes the inhabitants are wearing, because the cloth also prevents heat exchange of human body with the surrounding environment. And the more clothes are and warmer they are, the less heat exchange happens. And it is important in cases when the inhabitants are supposed to wear some kind of uniform, let's say working uniform or other. Um, of course, important is the positioning of the working or sitting places, the places where inhabitants spend longest time, most often, according to the window openings, and um, if any solar radiation is penetrating and hitting a certain area of the room, and how it influences the way the inhabitants feel. Those that are close to the window and get directly radiated and heated by sun, and those that are away from the window. Two important factors of the microclimate are the radiational temperature of the surrounding surfaces. They include the surfaces of the walls, the roof, the floor, and also the windows and doors, and the surfaces of the furniture, and also some technological appliances such as screens, keyboards, mouses, and the first thing is that it's good if that radiational temperature of all surfaces is equal, and it depends on the season. In cold seasons, it's good if that radiational temperature is higher, so it prevents the heat loss um, by touching, by getting in contact with them. And in hot seasons, of course, it's better if that radiational summer is sorry, that the radiational temperature is lower, so it can improve the heat loss and thus cool the human body. And also the next important factor is so-called effective temperature, and it's a um, combination of um, temperature, humidity, and airspeed movement. And usually the requirements of the temperatures inside the rooms are the normative requirements are based upon that effective temperature of the inner air. And these two diagrams show the comfort zones for radiational temperature on the left and effective temperature on the right. And it's logical that when the season is cold, people should want higher radiational temperature and an effective temperature with higher degrees, but with less speed movement, air speed movement. While in warmer seasons, the requirement for radiational temperature is lower, with cooler radiational temperature and cooler air temperature, but with higher airspeed movement. This is a comparing table showing different air degrees, different effective temperature degrees, the way people feel, and some physiological impact and the reaction of the body. So when it's 10 or 15 degrees, except for that people feel it as cold, there are also some lowering of the peripheric blood vessels. There are some muscle pains people feel, and some dryness in throat, nose, air, and skin. The comfortable zone is 20-25 degrees, and 30 and above 40 degrees it's considered as too hot or too hot. There is a strong, too much sweating, which causes loss of water. And there is also some danger for people with certain health condition from a heat stroke. The other factor of the microclimate is the air humidity, and it can be either absolute, measured by the amount of vapors in a single volume, or relative, which shows the percent of water vapors compared to the maximum water vapor amount that can be contained in the same air volume. The optimal um, the optimal extent of water vapor in air are between 40 and 60%. Below causes dryness and also some danger of static electricity, and above 60 causes hard breathing, some um, head spinning, and overheating.